Hey everyone. In this video I'm going to a couple of coding examples to show you how to visualize logistic regression results and also graph just the underlying binary data. Okay. And the running example that we're going to work with in this video and all the following videos for this week is the American National Election Study that we have actually already seen last week. Last week we looked at I think the 1992 election this week, and this is the cumulative file that basically combines multiple election years. And this year we're going to look at the 2000 election between George W. Bush and Al Gore. Okay, and we will model the same outcome that we also examined last week, in particular vote choice supporting the Republican candidate, so supporting George W. Bush, and we'll look at a couple of different predictors for that outcome. Okay, so in order to load these data, the first thing we have to do is we load the underlying RDA, which is basically an RData file that contains our data frame. And then we will just subset our the cumulative ANES file and just focus on data from the year 2000, and we'll save that as a tuple. So this is what we're doing here. We can kind of look at a couple of different variables, predictors that we could examine. Here in the first couple of models, what we're going to focus on is a feeling thermometer measuring ideology. So this is basically ranging from, in the original coding, from 0 to 100, whether you feel basically closer to liberal or conservative. Okay, so that's your ideological feeling thermometer. And then we're going to look at education, but also income and some other measures as well. Okay, so here just looking at this ideological, at this kind of set of variables, we have our outcome, which is again dichotomous 0, 1. 1 if the respondent voted for the Republican candidate. We have our feeling thermometer, and we have education, which is I believe a 7-point measure. There are a couple of different education measures in there as well. So if you kind of go through the code, you could also try alternative measures and compare the results as well, right? If this was an actual coding or an actual analysis, we would probably think about dichotomizing this education measure to just compare people with like college education versus not college education. But for the purpose of this analysis, we'll just treat this as a 7-point kind of quasi-continuous measure. Okay, same of course with the ideology feeling thermometer, and later on when we consider income, we'll treat that as continuous as well, just for the purpose of interpreting kind of quasi-continuous inputs and their coefficients. Okay. So if we kind of run a direct, like a simple bivariate logit model, now just using a single predictor, we can, for example, examine the coefficient or the relationship between voting for the Republican candidate in the 2000 election and this ideological feeling thermometer. Okay, so if this is our single predictor, we have our basic model specification, our model formula. R vote is the outcome, the ideological feeling thermometer is our predictor. We have specifying the link function, and that this outcome is binomial, and base this on our 2000 data. Okay, and if we look at the output, we have our basic regression result. Again, we have our intercept, which we cannot directly interpret because this is on the logit scale, so it doesn't directly represent a probability. And keep in mind that this intercept is basically the value or the expected value in this linear predictor for ideology, this feeling thermometer being equal to 0. So that's like all the way on one end of the ideological spectrum for someone who's basically extremely liberal, right? So we would be a little bit careful about interpreting this. If we wanted to get a better interpretation of the intercept, we would probably center this one, center the predictors by subtracting the mean, right? We talked about this also in the context of linear regression models, okay? Then just very briefly, and we'll look at coefficient interpretation in additional examples, including interactions, and we're going to go through that in a little bit more detail. Based on the basic regression output or the basic logistic regression output, we can directly kind of evaluate the direction of this relationship, where kind of larger values in this feeling thermometer are associated with larger probabilities to vote for the Republican candidate, which makes sense. Larger values are basically indicate feeling more closely to conservatives. And if we want to kind of get an idea of the substantive size of that effect, remember we talked about this divide by 4 rule, where if we divide this coefficient by 4, we get an approximation of the maximum increase in probability that is associated with a 1-unit increase in this predictor. Okay, and we'll talk about that more in detail as well. What we want to focus on first is just basically visualizing that result and kind of getting a better intuition based on on graphing both the raw data and our fitted logistic regression. Okay, and before we kind of jump into the logistic regression itself, I want to show you 2 kind of alternative visualizations that are also discussed, or one of which is also discussed in the textbook. And that is basically just looking at the actual raw data and then looking at binned probabilities, basically combining subsets of the data for different ranges in our predictor, and then just computing the expected value of our outcome measure to give some to provide some intuition about kind of the changes in probabilities for different levels of X. Okay. The way we can do this in R is by basically computing these different means. The first thing we have to do is we have to basically separate our predictor in different groups. Okay, and the way we can do this in R is use this cut function. What this cut function will do is it will basically take the variable IDEO field, so the feeling thermometer in ideology, and basically separate it in 5 different groups, okay, according to their values. So that will mean that the original variable is ranging from 0 to 100, so that basically means that it will assign all observations that have values from 0 to 20 to group 1, then 20 to 40 to group 2, 40 to 60 to group 3, and so on. Okay, so after we do this, we can then group that variable. So we basically just create a new variable that is basically now an ID for each of those groups, depending on the underlying feeling thermometer. Then we're grouping our variable by that new bin indicator, and then we're computing 2 different averages. The 2 averages that we're computing is, on the one hand, the average in the outcome measure, and that's just basically the proportion of votes for the Republican candidate in each of those bins. And then also the average ideological feeling thermometer in each of those bins, okay? And so in addition to basically graphing the raw data where we have just zeros and ones for different ranges of the input variable, we can now basically add these binned proportions for groups of observations, okay? And the way we're going to do this is we're first basically just specify the basic scatter plot, the raw data, where the outcome measure is just 0 or 1, and the input ranges from 0 to 100. But then we're adding additional points, which is based on this bins data that we just generated, okay? And we make those a little bit larger, give them a different color to make them kind of stand out from the actual raw data points, okay? And then what I'm going to do in addition is add a linear fit to compare kind of the average binned probabilities to our linear probability model. Remember last week we talked about the linear probability model as a, in a lot of cases as a really good approximation to kind of examine the relationships or examine predictors of dichotomous dependent variables, particularly in the case of experiments and things like that, okay? And this is the resulting R output, okay? On the one hand, up here we have all the observations, the raw observations that basically respondents who voted for the Republican candidate, who voted for George W. Bush. We have all the zeros down here. We have the different values in our feeling thermometer from 0 to 100. Okay, and we see there's a clear kind of relationship between identifying as more conservative or more liberal and voting for the Republican candidate and the Democratic candidate, okay? We also see these circles. These circles indicate our binned averages. So what we did here in this code was basically taking equally sized ranges of our feeling thermometer and then basically select all those observations that fall in that range and then compute the average of both our outcome measure and our predictor, okay? And so the resulting averages for each of those bins are basically indicated here as these circles, which is basically a simple non-parametric summary of conditional expectations for ranges of our predictor, okay? And on top of that, we have our linear fit, okay? As you can directly see, I mentioned last week that in some cases, the linear probability model can be problematic. Particularly, it can be problematic if we have cases where the linear prediction, the conditional expectation based on the linear model, basically exceeds the range of probabilities that we would like to have, which is a minimum of 0 and a maximum of 1, right? And as we can see here, given the relationship between ideology and a vote for the Republican candidate, we actually have cases, or we have ranges of inputs where either people feel very close to Republicans or very close to, very close to conservatives or very close to liberals, where the linear model actually predicts basically a conditional expectation that is larger than 1 or smaller than 0. And obviously we cannot interpret that conditional expectation as a probability anymore because probabilities are bound between 0 and 1, right? So in these cases, the linear probability model it actually has kind of runs into or is limited because there are ranges of data, ranges in our predictor where the expectation or where our prediction actually falls outside of the range of the values that we would like to predict. So we're not capturing the underlying data generating process, right? If we look at this kind of non-parametric, just summaries, basically conditional expectations for groups of observations using these bins, we already see that what we want to kind of have is, rather than having a linear fit, a linear probability model, we probably need some kind of S-shaped curve to really represent or model these underlying probabilities. And it turns out Logit and Probit are do exactly that, right? We talked about this from kind of a conceptual perspective last week, and now we're going to see this also in action using our actual models, our actual Logit coefficients, okay? So as a next step, what we want to do is we want to graph our Logit coefficients and the fitted logistic curves. But I think looking at the time, I want to keep the videos a little bit shorter, so it's smaller chunks. So I'm going to take a break here, and in the next video, I'm going to show you how to graph logit coefficients and fitted logistic curves as compared to the linear probability model and these binned conditional expectations that we just saw in this video. Okay.